Hello children, welcome to channel Sube. Children, today I am going to discuss question number 16 from the MCQ part of 2021 Physics New Syllabus paper. A liquid of density rho flowing at speed 3 times v through a horizontal tube of cross-sectional area capital A strikes a vertical wall perpendicularly and flows down along the wall without recoil. The force exerted on the wall by the liquid is 3 rho AV squared, 9 rho AV squared, 18 rho AV squared, 9 rho A squared V squared, 18 rho A squared V squared. So let us draw a little sketch. So suppose the density they have given as rho flowing at speed 3 times v, then the speed is 3 times v through horizontal tube, cross sectional area capital A, cross sectional area capital A, strikes a vertical wall perpendicularly and flows down along the wall without recoil. That means the water flows down without recoil, means without bumping or without rebounds. That means recoil, we can say recoil. So like this water falls down. So what happens here to the velocity? Velocity to this say v goes to 0, v equals 0 here, v equals 0 to this side and to right side, velocity goes to 0. So this one is u, the initial velocity. They have given it as 3 times v. Initial velocity before striking, initial velocity before striking, therefore let us write it closer to the striking point. Just before strike, the velocity is, initial velocity is 3 times v. After striking, the velocity v goes to 0. So you know, if you have experience, if you have solved these types of questions in the classroom as exercises, so you should know that we should apply Newton's second law for these types of questions. That means the force, what they ask is force. Force equals Newton's second law, mv minus mu divided by t. The rate of momentum change is equal to the force. So here this v equals 0, therefore this term we don't have to consider, totally it is 0. Then we can write F equals just mu divided by t. The negative sign we don't want, that means the force to the water column is to left, so that we don't want. We know there is a force towards the wall, only the magnitude they ask. So if you know the final, if we simplify this equation, apply these values and simplify this equation, if you remember the final equation, you can easily solve this problem. The final equation is for these types of questions where final velocity goes to 0 and perpendicular to the wall, rho a v squared. This is the equation, rho a v squared. If you remember this, you can easily solve this problem. So first let us solve using this equation. Suppose you remember this equation, then F equals rho a v squared means they have given v as 3 times v, 3 times simple v. So 3 times simple v is squared of whole thing. Then rho a 3 times 3 is 9, then v times v is v squared. Then 9 rho a v squared is the answer. Is the answer. So you have to select 9 rho a squared, a v squared, this one. So the question number 16. Question number 16, the second one is correct. But if you don't remember this equation, so you have to derive it. So I will remind you how to derive this equation if you have forgotten. So we have to consider there are two methods. One is we assume t equals 1 second. The other method we just take any t value, that way also we can do. So let us use this first method. So you have to consider the water column that leaves the tube per second, t equals 1. Per second the velocity is given u. Let us substitute 3v after that. Just let us say the initial velocity of the column. That means what is the meaning of this u? In a per second, in a time equals to 1 second, or we can say per second, this water column moves a certain distance. What is that distance? That is u. U is the distance per second. So we have taken time as 1 second. So in a 1 second time, the water column that is leaving the tube, the length of that water column, assume that this water column leaves in a second. So the length of that column is u, because the velocity is u. Velocity is the distance per second. So we have taken the time as second. So this length of this column leaving the tube per second is then u. So we have to find out the mass of this one, because we have to substitute here mass per second, m divided by t, mass per second. So the mass is equal to rho times volume. So what is the volume here? Cross-sectional area A times the length u. The length is u. So that is the volume of a cylinder. So now we know the mass per second. So we can substitute this into F equals m divided by t. M divided by t means this one is the mass, rho a u, then t is 1 second. Here we have taken it as that, times again u. So another u you have to write here, then you get F equals rho a u squared. So easy. That is the equation we used here. So you can derive it and use it, or if you remember directly you can use it. So that is all. We have chosen the answer. The answer is the second one. So this question is not a big issue. They have given easy questions this time, because I think you had various types of problems in those 2 years, that may be. So that is reasonable. So okay, so we have solved the problem. So now let us try to solve this question number 17 from the MCQ part of 2021 physics paper. Two point charges, positive 4q and negative q, are fixed at distance x apart as shown in the figure. Another point charge, positive q, does not experience a net electric force when it is kept along the same line at distance y from minus q. The relation between x and y is given by. They say that they have placed charge whose charge is 4q positive. Let us draw a red circle so that you will be able to understand this properly. In the exam time, real time, you don't have to do these things. So again they have placed the fixed point charge whose charge is minus q. These are fixed charge, they don't move. So here they say at this place this charge doesn't feel any force, doesn't experience any force. So why that happens? Then that is a neutral place. This one is must be a neutral place. How that happen? So this what they say, this positive q doesn't feel any electric force when it is kept along this place. It doesn't feel any force. Why that happen? The forces must be equal and opposite. The force exerting from this 4q, positive 4q, is directed to this way, to right direction, because positive repel each other. So this one is fixed, so it doesn't move. So therefore the force that this one feel must be directed to the right side, and the force giving by this one to this positive q, it is an attraction, because negative and positive. So this one doesn't move, it is fixed. So that force then can, by that force this charge can be moved. That means this one must feel force to this way, attraction to negative, towards the negative negative charge direction. So like that there must be two forces, each opposite to each other, and the magnitude also must be equal. Then this charge doesn't feel any force, because the forces are equal and opposite. So therefore we have to, there are two methods now we can solve this problem. We can equate forces, or if there is no force, the final field strength, field intensity, capital E, must be 0. Resultant field intensity must be 0. So we can use either force or the field intensity to this way, field intensity to this way. There is a field intensity to this way, or field strength we can say, that is capital E, and also there is another field strength to this way. We can either use force equation or capital E equation. So let us use E equation, so that is easy, intensity equation. What is the equation for intensity? 1 over 4 pi epsilon naught q divided by d squared. Because q1 q2 is there, the q2 is 1 coulomb, positive 1 coulomb. So therefore we don't write it. So then we get 1 over 4 pi epsilon naught from this one to this one. So distance is y. So y squared The charge of this one is minus q. We don't want the minus sign, just let us write q. Then it must be equal to the field intensity given by this one means this red one. So that also 1 over 4 pi epsilon naught q divided by d squared. So therefore 1 over 4 pi epsilon naught, then q is this 4q, then d is this total distance to this place from here, x plus y. 4 pi epsilon naught x plus y squared total, then 4q. You don't have to write all these things in the real time examination. If you have experience, you know that these people cancel each other, therefore you don't write, you just can write the essential parts. 1 over y squared equals, like that you can write, you know, these others cancel each other. So when then here 4. So to simplify this, we have to take the root at each side. So 1 over y equals root of 4 is 2 divided by x plus y. Square value, when we take root, it vanish. So x plus y equals 2y, then 2y minus y is y equals x. That's all. X equals y. So you must have solved a number of these types of questions in the classroom. Then this problem is not therefore a big issue. So x equals y. So the question number 17, the answer for that is 1, correct. I think you understood. We have to equate either forces or field intensities. Or you can even use the force equation. We know force equals q1 q2 divided by 4 pi epsilon naught d squared. That also you can use, because the force towards this from this red one, we can write F equals q1 is this one, 4q, times q2 is this one, 4q times q, 4q times q, then 4 pi epsilon naught, the distance x plus y squared. Then the force towards this way, F equals q and this q also divided by again 4 pi epsilon naught. Since we know the direction is this way, we don't have to use this signs. Here the direction is this way. Then 4 pi epsilon naught, the distance is y squared. So equating these equations also, you can cancel these q and 4 pi epsilon naught. We get the same equation, 1 over y squared equals 4 divided by x plus y. The same equation we get. So you get x equals y. So let us now do this problem, question number 18 from the MCQ part of 2021 physics paper. A block placed on a horizontal frictionless table is attached to mass m by a light inextensible string that passes over a pulley as shown in the figure. So like this, simple M is attached using a string which is going over the pulley. When released from rest, mass simple M and the pulley accelerate. If the tensions in the sections in the string are T1 and T2 as marked, which of the following is true? So when you look at the answers, we don't have to find out acceleration or something like that. Just we have to compare mg, T1 and T2. We have to compare. So it is not a big question. Therefore, you know, they say this one accelerates this way. There is an acceleration to this way. So there must be mg. So let us mark it like this. So to accelerate this way, mg must be greater than T1. T1 must be small, otherwise how can this one move to downwards? Accelerates means it must move downwards from zero velocity, because they have released it from rest. So the initial velocity is 0, and they say accelerate. If it is accelerating, the velocity must change. Velocity must achieve some value denoted by v. So to gain a velocity, there must be a resultant force. Therefore, mg must be greater than T1. So that is the first relationship we can get. So then they say this pulley also accelerates. It must accelerates to this side, this direction. The pulley must accelerate to this direction. So T1 must be greater then, because the T1 is here. This force is T1. This force is T2. These two forces you have to consider. Let's keep here. So let us take this one. So these are the forces. To rotate the pulley to this direction, first of all you must be able to identify the direction of the pulley. Even there are some people who can't understand the direction of the pulley when this mass is moving this way. When the mass is moving this way, the pulley must rotate to this direction, not to this direction, because the string is going like this downwards with this mass. String also going down. When the string going down, it rotates the pulley to this direction. So therefore, T1 must be greater than T2. T1 must be greater than T2, should be smaller. So we have to combine these two terms now. So mg is the biggest one, then T1 is here, T1 also here, then T1, then smallest T2. So like this. This is the final relationship. So let us check now. Mg, there are no any equal terms, therefore we can remove these things. Then only these two we have to compare. So obviously this one is the correct one. So the correct one is the fifth one for this problem. Question number 18. Question number 18, fifth one, correct. So it is not a big problem. You can understand it. Children, now let us try to solve this problem. Question number 19 from the MCQ part of 2021 Physics New Syllabus paper. The variation of product PV of pressure and volume with pressure P. Volume with pressure P for a fixed mass of an ideal gas at constant temperature is best represented by. Now you must remember, you must recall Boyle's law here, because when you read these words, it should come to your mind. They are talking about Boyle's law. So what is Boyle's law? PV, the multiplication, is equal to constant, whatever the value V, but finally PV must be constant. So variation, they have taken P to the x-axis. So however, whatever the value is P, but PV multiplication should be constant. It should be constant. So this one is the answer therefore. Even you can take V to this axis, doesn't matter, because however PV multiplication must be constant like this. So answer is the fifth one. Very easy problem. Question number 19, fifth one. 19, fifth one. Yes, PV multiplication is constant. Children, now let us try to solve this problem. Question number 20 from the MCQ part of 2021 Physics New Syllabus paper. The diameter and mean density of Jupiter are 11 times and quarter times respectively to that of Earth. If the gravitational intensity at the surface of Earth is 10 Newton per kilogram, what is the gravitational intensity at the surface of Jupiter? This we have to solve by using Newton's gravitational equation. So say, assume that this one is the Earth, this one is the Earth, and assume that this one is the Jupiter. So let us denote. So mass, no, first of all the diameter and mean density. Diameter is 11 times. If the diameter is 11 times, the radius also 11 times. So let us take radius of this Earth as just r. So here in Jupiter the radius must be then 11 times, that means 11 r, the radius. So the density, if the density of Earth is sigma, then sigma divided by 4 in the Jupiter. The density is sigma divided by 4, because they say quarter times respectively. So also they have given the gravitational intensity at the surface of Earth. That means look at these units. Look at these units. 10 Newton per kilogram. Per kilogram, that means 1 kilogram. If we place the 1 kilogram object here, 1 kilogram, mass is 1 kilogram. If we place the object whose mass is 1 kilogram, the force acting on that by this Earth is 10 Newton. 10 Newton per 1 kilogram. So let us apply Newton's equation for these people, these two. Let us take mass as capital M of this Earth, then mass of this object is this one. So G F equals G M1 M2 divided by d squared. That is the basic equation. So F is given 10, then 10 equals G times M1 is the same mass of the Earth, M2 is this 1 kilogram, then times 1 divided by d is this radius, because very close to the surface. this object is kept very closer to the surface, then the distance is r, then r squared. So we get 10 equals g m divided by r squared. So let us keep this equation aside. Now let us consider this one. So here what they ask is the gravitational intensity at the surface of Jupiter. So here if we placed a mass of 1 kilogram, simple m, then the force acting on this 1 kilogram is called simple g. So here it was 10. We know, we write normally 10 as the gravitational acceleration. We write 10 as ms minus 2. Normally we use these units, but here the units are different. The same idea. So here also if we kept 1 kilogram very close to the surface of Jupiter, then the force acting on it is called the intensity. So let us now apply the Newton's equation to these people. Then mass, how many mass? Let us say mass Jupiter. So let us write the force equals g m1 m2 divided by r squared. That is the basic equation. So force is going to be now g, capital G. M1 is m Jupiter and m2 is 1 kilogram, this one 1 kilogram, divide by r is this 11r, because this distance is 11r from center to center, 11r, 11 squared r squared. So we don't have to write this 1, g equals g m Jupiter 11 squared r squared. So here m earth, here m is m earth, So now we have to find out m earth and m Jupiter. So let us find it like this. So it is a sphere. What is the volume? Volume equals 4 divided by 3 phi r cube. This is the equation to find out the volume of a sphere. So the density equals mass divided by volume. So we need mass. Mass means capital M of earth equal sigma times volume. So we have taken the density as sigma, so let us take the same thing, sigma. Volume is this one, 4 divided by 3 phi r is r cube, so this one. So we have to now apply it to this equation. 10 equals g m earth means sigma 4 divided by 3 phi r cube. M is okay, then r squared. So we can cancel r squared, then only 1 r is there. Then 10 equals 4 divided by 3 g sigma phi r. That's all we have. So let us keep aside here. Now let us go to this one. So here also we have to find out m Jupiter. M Jupiter equals the same way m Jupiter equals like this, sigma times volume, sigma times volumes, but sigma here is sigma divided by 4. They have given that sigma is very lesser. Sigma is sigma divided by 4, 1/4 of sigma, then sigma divided by 4 times volume, times volume. Volume is 4 divided by 3, 5, r, r means 11r cube, then 11 cube r cube, like this. That is the mass. So divide by 11 squared, these people I write, and r squared. So that is the equation. So let us cancel whatever possible. 4 cancel, then r squared cancel, only 1 r there. No, this r squared, this one, 11 squared, like that. Then m Jupiter equals sigma divided by 3, then 5, 11 r. That's all. 5, 11 r 3. Then let us take this equation, and let us cover these people. 4, 3 is there, 3g, this term, 3 is there. What happened to g here? I haven't written g here. This g must be here. I had forgotten. G must be here. So g is there, sigma is there, 5 r. Here, from here, let us use this black color one. So there also we have to write g. G is there. Nothing happened to g. So 3 is there, g is there, sigma 5 without 11, this r. So all these are equal to 10 divided by 4. 10 divided by 4. Let us write. Let us take this 4 here. 10 divided by 4 here. This 4 to left hand to the denominator, like this. So instead of these things we can write what? These terms we can write 10 divided by 4. Then m Jupiter equals 10 divided by 4, then 11. This 11 is here. It is not enclosed there by red line. So multiply 11 times 10, 110 divided by 4. If this were 100, then divided by 4 is 25. Then the remaining 10 divided by 4 is 2.5, then 27.5 Newton per kilogram. There's a mistake. What we have written here? Here it should be G. I have written mj, not mj. That should be simple G. Simple G, because this G should go along. Simple G. We found G of Jupiter. So that is the answer, 27.5. This one. So the first one is the answer for the question 20. 20s, the answer is first one. Okay, correct. You understood, I think. So you do it alone. After just having a glance at this solution, you try to do alone. Okay, well children, if you haven't subscribed my channel, please subscribe before you leave. If you haven't still subscribed it, watch my videos again and again. So see you tomorrow at 6 o'clock in the evening. Goodbye.